jhat 塾
Please hit subscribe.
This problem appears at the qualifying examinations for applicants for Japanese government or MEXT scholarships 2020. This problem is from the 2020 College of Technology Mathematics questionnaire. The answer key and the original questions are linked in the description.
Calculate the area of the triangle whose vertices are 1, 1, 1, minus 1, 0, 1, and 1, minus 1, minus 1 in the XYZ space. This is a straightforward problem when we recall that the vector cross product, the magnitude of that actually gives us the area of the parallelogram determined by two vectors. And certainly these three vertices form two vectors which correspond to two sides of the triangle, and the third vector is a diagonal of that parallelogram. And so what we need to do to solve this is just find the two vectors, any two of these, any two combinations of these vertices would correspond to those two vectors, and then we assume that we have a parallelogram from those two vectors and just take 1/2 of that area of that parallelogram, and there we will have the area of our triangle. The vector cross product of two vectors A and B, which here we define to be the vectors with these components, is denoted A cross B. Here, let's call it P. The components of P can be computed from the components of A and B. The first component, P1, is the difference A2B3 minus A3B2. The component P2 is the difference A3B1 minus A1B3. The third component P3 is the difference A1B2 minus A2B1. The magnitude of this cross product is denoted using the usual symbol, the absolute value signs, and this can also be computed from the magnitudes of A and B. That is, the magnitude of P is the magnitude of A times the magnitude of B times the sine of the angle between the vectors A and B. This formula is also reminiscent of the formula for the area of a parallelogram whose sides are of lengths A and B. And therefore we can say that if we have a parallelogram formed by the vectors A and B, then the area within that parallelogram is given by the magnitude of the cross product of A and B. For example, if we have two vectors A and C, here we draw A to be this and C to be this, and if we form a parallelogram, that would be extending this bit here, which is also A, and this bit here, which is also C. Then the cross product of A and C can be computed as follows. Here we call the cross product P, we denote the cross product A cross C, and this is the result when we compute each of the components using this. Notice that each of the numbers here is color-coded to match the colors here. And this cross product is this vector here. And if we get the magnitude of that, that will give us the length of this vector and the area of this parallelogram here. And that area is also equal to this. Here we rewrite the vertices of our triangle. We call it P1, P2, and P3. And then we define two sides of this triangle as vectors. In our case, we choose one side to be from P1 to P2 and the other side to be P1 to P3. Any two vectors would work. It doesn't have to be in this order. We could have chosen P2, P3 for one of the sides, but for simplicity, here we choose P1 and P2 and P1 and P3, and we call them side A and side B. And computing side A is straightforward because that is just P2, the coordinates of P2 minus the coordinates of P1, and there you will have this vector. This is the side A, and a similar process is done for side B. We just subtract the coordinates of P3 and the coordinates of P1, and so we get this vector. Now we have these two sides of the triangle. These two sides will now determine that parallelogram. And to get the area of that parallelogram, we just need to get the magnitude of the cross product, which is the cross of A and B. And then we take 1/2 of that to get the area of the triangle. Here we just applied the formula for the cross product. And so the cross product of A and B is this. Now the absolute value signs here indicate that we need to get the magnitude of this vector, the cross product. And so the magnitude is just the square root of the squares of each of these components. And so we obtain this, and finally this one reduces to this, which gives us this. If you learned something new today, please help my channel by clicking the subscribe button and the bell for the notifications. See ya!
Please hit subscribe.